So now let's get back to the memory allocation. So as I told you, all the functions of your class will get memory at the static time, at the class loading time in the method area. That area is called method area. Now, as I told you, the objects will be getting memory in the heap area, and the objects will be getting memory dynamically. Okay, minded dynamically. So all the objects in Java are the runtime entities. That's why they are called runtime entities. So what is object? Object is just a buffer, right? So object is nothing but composed of its data members and nothing. Okay. So as we took the example employee, so the employee class was having two data members, right? So this is an object. Whenever it is created, so it will be created in a heap, and what it will contain is the name and the salary. Just the name and the salary. No function, nothing. So just the data members of that object. So now we will see the full diagram of the class in the memory form. So till now you have seen the method area in which the functions get loaded at the class loading time, and at runtime objects are loaded in the heap area, right? So now there is a third type of memory area that is called the stack. So what it is used for? So whenever you create an object like employee emp1 is equals to new employee, so emp1 is the local variable to the main method. So like in any method, like in the get method or in the show method, you create variables like int a is equals to 10 or something like that. So those variables are the local variables that are very local to that method. So that cannot be accessed outside that method, right? So those local variables are managed by stack only. So if you create an object also, employee emp1 is equals to new employee, so that emp1 is the variable, right? It's simply a variable name, but it is of that class type. So that emp1 will hold the RID as I told you previously. So that new operator will create an RID, and constructor will return that RID to this variable. So this variable will hold the RID, that is the address of some object that is created by the new operator, right? So this object's address will be held by this variable. So this is a local variable and this is a class instance, or you can say object. So this, the address of this class instance is held by this variable. So that is of 4 bytes. So now whenever you call a method, right? So emp1 maybe emp1 dot get. So that emp1 will call this method in the method area. So it can call any method, right? And if you create another object like emp2, so employee emp2 is equals to new employee. So then emp2, that variable that is local, right, that will be created in stack. So that will hold the RID, the new RID of the new object. So whenever you type new, whenever you execute the new statement, how many statements you are executing, that many objects will be created in the heap. So this new object, the RID of this new object will be held by m2. So whenever you execute emp2 dot get, so you are calling the get method. So this is a static memory, right? So the functions are loaded once. So these functions are shared by all the variables, or you can say shared by all the objects. Okay, so whenever you call emp2, so this get method will be called. Whenever you call using this variable, the get method, so the same get method will be executed. So no new get method. Like whenever you create different objects, the different memory will be executed, will be created. Okay, but for methods, no new memory will be given. The methods are loaded once only, because the same lines of code will be executed for different objects. Hope you understand. One question might arise here, like the functions are getting memory at the class loading time, the objects are getting memory at the run time, but what about these local variables? So the local variables do not get memory either statically or dynamically, but only when the function is invoked, because it depends on the flow of the execution of the program. So whenever it encounters the local variables, it will create it in the stack and are removed with the end of function or the method. Okay. So as I told you, all the functions are getting memory only once, and all those functions are shared by all the objects of a particular class, right? So and whenever you call a function using a particular object's reference, so how will the function know which reference has called it, right? How that function will know on which object it has to operate? So as you remember in the program we took, right? So we use the dot operator, like we call the get function like e1 dot get or e1 dot set function, right? So that dot operator, what it does is it associates function and the object. So whenever you call a function using the dot operator, it passes the RID, that is the reference ID of the calling object, to the function, so that the function will know which object has called that function. So it will operate on that object. So that's why it's called association operator. So as I told you, the local variables do not get memory either statically or dynamically, but they get it only when function get invoked or and removed in the end of function. So let's see how it works. So there is a concept of stack frame. So let's see. So let's suppose you are calling a main function, right? So whenever you call any function, that function will get an entry in the stack frame. So like for example, you have called the g method or g function within the main function. So then the function will get entry above the main function. For example, you are calling d function in the g function. So d will get an entry above the g function. So likewise, it maintains the stack frame in the memory. So whenever in the end, whenever the execution gets completed of the o function, of the last function, okay, so if you know stack is last in first out. So whatever is on the top will get removed first. So whenever the functioning of the o method will get completed, so o will be removed from the stack. So likewise, the variables, the local variables which are used in this o method will get removed from the memory. So likewise, then the d function will get removed, then the g, and then in the last, the main function will also get removed from the stack frame. So now we can properly understand this statement about instance data members from where we started the tutorial, right? So always keep those properties of an object as the instance data members of the class whose values are keep changing for an object, right? So like in the example we took for this tutorial, we took like employee class. So all the employees will have the different salary and different name, right? So you can keep those data members as instance data members and not the static one. So we will take the static data members in the next tutorial. So now we'll quickly see what are instance member functions also, as we have already done, but we will quickly wrap up. So set and the show methods that we wrote in the example are the instance member functions, because they are dependent on an instance of a class for calling them, right? So when we write like employee E1, we created two objects E1 and E2, and then we called the set method, right, by passing two parameters name and salary. So set method cannot be called like this because it needs an instance to be operated on, right? So that's why if you write it like set and you are not calling the function, this instance member function, using one object, then you will get an error like set does not have the address of the instance. So it is dependent on the instance. Like here you can see we are creating one object and then another object in the heap. So there are two objects in the heap, and this set function do not know like on for which object it has to set the values, right? For this or this. So it is an ambiguity. So instance member functions needs an object. So now as you know what are instance functions also, or instance member functions. So let's quickly wrap up on this also. So always keep that behavior of an object as an instance functions of a class which is performing a task for a particular object, right? For example, like for a employee class, if a function is calculating the salary of the employee, so salary of the employee will be different for each employee. So keep that member function or keep that behavior of a class as an instance. Okay. Or another example could be the method which is printing the attendance of a particular object. So keep that function as instance member function. So that's it for today guys. I hope you like the video, and if you have any questions you can comment in the below section, or you can message me personally also. I will definitely get back to you. And please subscribe my channel and share the video.